Welcome back to the series of videos related to Fourier transforms. In the third video in this series, we are actually doing a problem. So now we have a problem in our hand, that is, a function is given, and you can see the function is given in a splitted manner, and the function is 0 if that value of t is greater than a by 2 and less than minus a by 2, and it's 1 in between them. And if you plot the function, you will get a shape like this. Now we are going to find the Fourier transform. So we know the equation, and if we take the Fourier transform that function, we will get another function, a transformed function in frequency space or omega, and that is equal to 1 by root 2 pi. It is the constant that we physicists usually use. In mathematics you may use some other constant, and in physics we usually have that 1 by root 2 pi. By default it is there. Minus infinity to infinity, our function f of t, then e raised to minus I omega t dt. Now you take that root 2 pi in the other side, you can write it as root 2 pi into f of omega is equal to, now what is the function? So it, even though the definition is from minus infinity to infinity, now the function we can split it as, first part is minus infinity to all the way up to 0, sorry, all the way up to minus a by 2. From minus infinity all the way up to minus a by 2, the function, the value of the function is 0. Okay, 0 and dt plus, now in between minus a by 2 and a by 2, the value of the function is 1. So f of t is 1 multiplied by e raised to minus I omega t multiplied by dt plus, again from a by 2 to infinity we have 0. The value of the function is 0. So the big function that reduces to a simpler form, now it's minus a by 2 to a by 2 e raised to minus I omega t dt. So very simple integral, then so that is equal to 1 by root 2 pi. So we know the integral of e raised to minus I omega t. It's the answer is e raised to minus I omega t. We are integrating in dt, right? The divided by minus I omega from the limits minus a by 2 to a by 2. So that is equal to 1 by root 2 pi, put that minus sign, I omega, take the minus in the to the numerator, and you will get, substitute the limits, minus I omega a by 2 minus e raised to plus I omega a by 2. When you substitute that minus lower limit, of course you are going to get e raised to plus I omega a by 2. Now so I can rearrange this equation. This is equal to 1 by root 2 pi into I omega, and take that minus sign into the bracket. So you will get e raised to I omega a by 2 minus e raised to minus I omega a by 2. And we know e raised to ix minus e raised to minus ix divided by 2i. This is equal to sin x. This is equal to sin x. So you can now, what is absent in this, compare the two equations. Here 2i is absent, so I put a 2i. So in order not to change the value of that content, you put a 2i in the numerator. Now we have got everything what we need. Now that is equal to 2i divided by root 2 pi I omega, and now the bracket, that is equal to sin x. Here instead of x we have omega a by 2, so sin omega a by 2. Now you can cancel that I and I, then 2 by root 2 will be the 2 by root 2 pi will be equal to root 2 by pi sin omega a by 2. Okay, this is the final answer. So the Fourier transform of a function, of course you can see this is a function in omega. We have transformed that function into a function in omega. The answer, final answer is 2 by root 2 pi. There is an omega, one omega is also there, divided by omega. One omega is also there. So the answer is sin omega a by 2 divided by omega. Okay, thank you for watching. Please subscribe the channel. Okay, we will see in the next video with some other problem. Thank you very much.